Okay, so we're going to finish up experimental probability today. And today we're going to do some word problems and we're going to compare both experimental and theoretical. So we're going to read through these problems. I'm going to talk you through how to solve them and then you'll try on your own. A six-sided number cube is tossed one time and shows the number 4. What is the experimental probability of the number cube showing the number 4? Well, remember, experimental probability is the number of trials on the bottom and the number of times the event occurred. So the event is showing the number 4. Well, it showed the number 4 one time. And how many times did they do the experiment? Well, they only did it one time. They tossed a number cube one time. So in this experiment right here, there's a 100% chance that this will land on 4 because it did. Now we continue the experiment. After 5 more tosses, the number cube has shown the number 4 twice out of the 6 total tosses. So calculate the experimental probability of the number cube showing 4, taking this new data into account. Well, it's landed on 4 twice, and it has been tossed a total of 6 times. Well, 2 out of 6 can be simplified, correct, to 1/3. So we went from a 100% chance that it would happen to a 1/3 chance that it would happen, or a 33.3% chance it would happen. Now, I continue the same experiment another 6 more times. Now the number cube has shown the number 4 twice out of 12. So 4 has shown up 2 times out of 12 trials, and 2 out of 12 can be simplified to 1 out of 6. Now, if you notice, I did it once, that probability of it happening was very high. Then I did it again, still pretty good odds, 1 out of 3. And then I did it more and more, and I've got 1 out of 6. Now let's talk about theoretical probability. Remember, theoretical probability is only based on the number of outcomes. So what is the theoretical probability of the number cube showing 4? Well, there are 6 total outcomes, right? And how many 4s are on that number cube? There's only 1. Now, I want you to look at the progression. Just doing the experiment once didn't help us. Doing it 6 times, okay. Doing it 12 times, and look, the more I did it, the closer the probability got to theoretical. All right, so 100% chance after 1, 33% chance after 6, 16% chance after 12, and 1 out of 6 is about a 16% chance. Okay, so which of the following statements is true? Experimental probability gets closer to theoretical probability as more trials are performed. Or theoretical probability is always less than experimental. Well, theoretical probability isn't always less. It could be more, it could be less, it could be equal to. So I know that one's not true. Experimental probability will always be the same as theoretical probability. Well, we just proved that one false. Experimental probability was more, and then it was more again, and then it was the same. So it could be more, it could be less, or it could be the same. So that one's false. So we've eliminated those two. The last statement says theoretical probability changes depending on the experiment. So now I have 2 statements that I have to determine which one is true. Well, theoretical probability changes depending on the experiment. Well, theoretical probability has nothing to do with an experiment. Theoretical probability is what should happen based on the outcomes in that event, not in the experiment. So we said that the more times I do an event or a trial, the closer I would get to theoretical. So there is my correct answer. So on a trip, Dylan sees 125 vehicles with Montana plates and 40 with non-Montana plates. On the trip back, what is the experimental probability? So that's important. Experimental probability that the first car he sees is from Montana. Well, experimental is what did happen. So I want to know the number of cars he saw and how many of them were from Montana. So he saw 125 vehicles with Montana plates and 40 with non Montana plates. So this is a combination. So he saw a total of 165 cars, and 125 had Montana plates. Now, I know that that is not in simplest form. How do I know that so quickly? Well, because they both end in 5. So if they both end in 5, it is able to be simplified by 5. So I'm going to divide both of these numbers by 5. 125 divided by 5 is 25. And 165 divided by 5 is 33. So I am going to simplify this problem to 25 over 33. That is experimental probability.